Hey guys, I'm going to help you find the center of your yo-yo. And just so you understand how I'm doing this, going back to geometry class real quick, I'm going to use a couple kind of main facts from geometry class. If you remember, a segment whose endpoints lie on a circle is called a chord. You would have learned this theorem that a radius or a diameter, something coming from the center, if it's perpendicular to that chord, then it bisects the chord. So in essence, the perpendicular bisector of a chord is going to pass through the center. Okay, that's kind of the bottom line for us. If we have a perpendicular bisector, okay, it's going to go through the center. That's a key fact to explain why this is going to work. Another key fact is a relationship that says points that are equidistant from the endpoints of a segment. So in red here, if you can see the color coding, in red I have a segment with endpoints, and then I have a point here that is equidistant from these two endpoints. You can see that distance and that distance is the same. And I have a second point. Also, I did a couple where the distance it is from one endpoint to the other is also the same. So points that are equidistant from the endpoints of a segment, they must lie on the perpendicular bisector of that segment. We're going to use this to make sure we find the perpendicular bisector, and if we have a perpendicular bisector, we know it's going to include the center. Okay, so that hopefully gives you a little background into what we're doing. All right, so I have this yo-yo, and our yo-yos, as you can see, they have a flat area, and where the flat area stops and it becomes curved, I can see a circle. And what I'm going to do, I'm not going to draw the actual chord, but I'm going to give myself a couple points that are going to represent the endpoints of a chord. Okay, and so I'm just going to make a mark right here, kind of a dot right on that lip. I probably need to make it a little bigger so you guys can see it. Okay, so there's one, and then here's another. And what I want to do is I want to find 2 points, not one, but 2 points that each one is equidistant from these two endpoints. And to do that, we're not going to take the time to use a ruler. We're going to use a compass. And a compass is going to be our tool to hold a set distance. Okay, let's make sure this, I'm going to make it a little bit smaller. Okay, and so what I'm going to do is from right here, I'm going to put my needle right on that point, and I'm going to try to be as precise as I can with each of these steps. I want to find the perpendicular bisector of basically this imaginary segment where those are the two endpoints. And so I'm going to use this as the center and this is an arc. Every point that's on that arc, you can see, is the same distance from that point. And then I'm going to move to this point over here. I'm going to use that as my center, and I'm going to swing an arc with the same radius. Where those two arcs intersect, okay, is a point that is equidistant from those two endpoints. So we'll keep that in mind. I'm going to shorten the radius. So there's one point that is equidistant from those two endpoints. I'm going to make a second one now. So I'm going to try to be careful to get right at that same point. I'm going to swing my compass now with a different radius, and I'm going to do that from both of these endpoints. Okay, and there is a second point that it is equidistant from these two. So now those 2 points are both supposed to lie on the perpendicular bisector. So I'm going to take a little bit of time and try to line up, okay, my pencil and that straight edge and ruler. And I really want to make sure I go through as precisely as possible those points. Sometimes I hold my pencil on that point and then try to bring the ruler to it till it meets up. And then I'm just doing this kind of lightly. I'm going to draw that line. Okay, that line right there, these marks where the arcs are don't mark the center of the yo-yo. But this line is supposed to be the perpendicular bisector, okay, of that chord. And what do we know about the perpendicular bisector of a chord? Is that it must go through the center. So somewhere on this line is the center. Somewhere. I don't know exactly where. If I repeat this process again, though, I will find a second line at a different angle that also must include the center. And then where they intersect is going to be the center. So I'm going to erase these arcs. Okay, really all I want is the line. And I'm going to repeat this process. Okay, and I can actually use one of these points. I just don't want to use the same two. And so how about I make another mark over here. You can see I've got one here, and I will repeat these steps. Now from in here, I'll erase this, make sure I know which 2 points we're using now. Okay, I can come back and erase things a little better later, but these 2 points, and we're going to repeat the same process, taking time to try to be as precise as possible, getting this point on here, swinging an arc. That represents all the points that are a set distance from that center to that arc. I'm going to repeat with the exact same distance. Okay, and so there's a point that's equidistant from those 2 endpoints. I'll widen my compass here and repeat. And you might have more precision if you actually separate these points a little bit. I'm just trying to do this quick for the video. Okay, in theory, this is the way it should work. If I could be precise every time. Here are 2 new points that should lie on the perpendicular bisector of that chord. And what we know is that the perpendicular bisector of a chord must go through the center of a circle. So I'm going to line that up. I would draw this lightly. And having followed that, where those cross, this point right here should then be the center of my yo-yo. Okay, I think this one got off a little bit, if you can see, but I was going pretty fast at the end. So I could try to maybe shorten this up and see if I can guide a different. I'm going to change the radius and come back and do these. Oh yeah, yep, see, look at that. This is more to the right here. Okay, so if I come from right here to that point, it's going to be, I think it's going to look a little more accurate. Okay, so that would put my center right here. There you go, and that's the process for finding the center of the yo-yo. When we take the yo-yo over to the CNC, that's the point that we're going to have become our origin, our 0 for the x, 0 for the y, and then we'll bring the bit down right to that height, and that'll become 0 for our height. So there is how you find the center of your circle.